do as a part of a safety share to indicate that recently few days it has been quite hectic in terms of being cold and hot. I'm in Limpopo right now, and yesterday it was really cold, and today it's changing. So just make sure that you're taking care of yourself, you're dressing warm, and staying, within shades, or so. Yeah, so today I'll be sharing a presentation on the challenges in opencast dewatering within crystalline aquifer. So as Nolene indicated, my name is Despina Tshipala, and I'm working for Master Drilling and working as a geologist/hydrogeologist. So the structure of my presentation today, it will start with an overview of the Master Drilling Group, and just indicating their service offering and also their footprints, and then go on to indicate the purpose of opencast mine dewatering in the operation that we are working on as contractors. So I'm based in Mogalakwena Platinum Mine, and we had two projects. Rather, we had two projects, and the dewatering project had since ended. Right now, we are working on rate control project. Then I'll go on to just give a brief overview of a crystalline aquifer, and also indicating the dewatering techniques that we were using during the project, and then go on to outline the challenges that we are facing. And I think and believe that it's some of the challenges that the opencast mining are facing worldwide, and then propose some integrated mine dewatering strategic plan in order to bring about solutions to this, to the challenges that we're facing as hydrogeologists. So on to the Master Drilling Group. So I'm working for Master Drilling Exploration, which is one of the subsidiary of Master Drilling Group. So it has its head office in South Africa, and the footprint of Master Drilling is all over the world. As you can see in the picture, we have footprints in the Central North America, South America, Africa, and the rest of the world, with the different financial diversification, as well, as you can see in the picture. So, and Master Drilling is very diverse in terms of their service offering. We have ranges from raise boring, where we drill for tunnel and also for shaft sinking. And we also have percussion drilling, grade control, diamond drilling, and slim drilling as well. So we are quite diverse in that regard. So going on to the goals of the opencast mine dewatering. So in the operation that we're working on, we were one of the contractors that we were drilling for the dewatering. So the purpose of the dewatering projects, mainly they are implemented in order to ensure that we mitigate the risk in relations to water that is encountered during drilling, and also to ensure that we have stability of the high walls in the opencast, and also ensuring the visibility of benches as we are doing production. We also have to ensure that there is regulatory requirements that are met in terms of the Department of Water and Sanitation, where they require a certain amount of discharge and recharge that needs to be quantified according to the regulations, and also ultimately to ensure that there is enough mine productivity that is occurring with groundwater levels being lower than the production levels. So on this slide, I'll just share a brief review on the crystalline aquifers, the characteristics of the crystalline aquifer. So a crystalline aquifer is normally characterized by an unconfined aquifer that is normally consisting of a regolith or soil or any decomposed rock that is mostly high in porosity, as you can see on the picture on the left, with high porosity. However, mostly because it's comprising of clay and mud material, it has a lower hydraulic conductivity. Then we have the confined aquifer that is mostly comprising of mafic and ultramafic rocks that the hydraulic conductivity will then depend on the fractures that are within that lithology. Okay, so in terms of the dewatering techniques that are undertaken, normally we would have the dewatering design and surveys where the hydrogeologist on the mine side would do the planning of the location of the boreholes that needs to be drilled, and also put in with liaise with the surveyors as well to survey those boreholes. And then would have the borehole design and drilling specifications. So the contractors or the client would ensure that we have specifications in terms of the borehole construction, what diameters we need to use of the drill beds, the casing that needs to be put in there, whether it's steel casing or a perforated casing, and high depth that needs to be drilled for those holes, and also determining what needs to be put in there in terms of the overall borehole construction. And then would have site suitability assessments. This involves risk assessments that are done there, because you'd find that sometimes would drill in areas that are a bit remote, so would have to be cognizant of snakes and all bees and all those things. So, and also we need to have done inspections on our machines as well. So if you can see on the top left of your picture, it's one of our rigs. They're from Thor producers. So we'd have that with the front of the rig. We have a bucket there full of the rods that are about 6 meters in length. So this is the typical drilling machines that we use. Then we'll produce the chips. We use it's a percussion drilling. So the material that we produce is what you can see there in the middle picture, the chips. So would have to then log them. I would log them and check the lithology and try to identify structures, the oxidation areas, and also the contacts, just to ensure that we have the stratigraphy of each borehole that we drill. Then when we are done with, we'll then do, if for an example, we encounter water strikes in these holes, then we will do a blow yield test or an airlift test, where we would try to find the discharge rates in those particular boreholes. From there, we'll then do borehole rehabilitation, as you can see on the right, the far right picture. So that's basically what we do in order to conduct the dewatering in the technical side of things. Then we also have another part where groundwater is occurring on the surfaces of the benches, and we have different sumps that are most of the time they disturb the production as well. So would have pumps being put into these sumps, and they dewater or empty the sumps. Mostly you would have this water being redirected to other sumps that of less importance areas, or they are taken to for dust suppression. So that's basically what we do in terms of the dewatering. So in that process, would find that there is some challenges that we're facing. Firstly, in relation to the complex of structural geology in these crystalline aquifers, we have different characteristics, the different fracturing that is in most cases not connected, causing compartmentalization in aquifers. In some cases, would drill holes that are about 50 meters apart. In one hole, would encounter water, and in another wouldn't have anything. So those were some of the challenges that we encountered, and also the lack of finding the sources, or rather identifying the source of the groundwater that we encountered. As we know, we have different sources which comes from the seepages, from the surface reservoirs, and also surface water, and also rainwater. And also we could also encounter ancient groundwater that has high or long-term residence in these aquifers. Another challenge that we also encountered is the gaps in characterization of the unconfined and confined aquifers. This includes the disconnect in terms of the drilling programs that are within. There is no proper link between, for an example, the diamond drilling, where it's much proper in order to identify the structures, and also identify the zones that are potential for groundwater flows. And also ultimately the gaps also in the hydraulic properties, which includes lack of information in terms of understanding the hydraulic properties with regards to the ore body, and also the hydrostratigraphic units in the aquifers that we encounter in the mine. Other challenges that we were facing are loss of data and equipment. This involves downhole data loggers, like the one that you can see on the top right there. It's one of the divers that we use to capture pressure and temperature data in our boreholes. So in some cases, you'd find that we have detachments of these loggers from the rods. Then we tend to lose them, or sometimes we find that they are destroyed while still in hole, so we are unable to recover the information. So sometimes we find in a situation that holes are, the formation is not favorable. Some of the holes, we lose them, and then we are forced to abandon them. In rare cases, we have deviations of borehole construction from the planned information, where we have challenges where instead of installing perforated casing, and we have solid casing, which puts us in a risk of sealing off the water strike locations, which also brings a challenge, because then we lose some crucial information in them. And also, we also, in some cases, we have production of the mines getting in the way of dewatering as well. For an example, where there is limited space or rather space that because of the load and haul that occurs in pits. For an example, as you can see the picture there is stockpiles being in the way of survey, sometimes in the way of surveyed locations where we then have to wait for such areas to be cleared for us to then start drilling our dewatering holes. So, and sometimes it's also gets to be impossible to drill such holes because then we come in the way of blasting. So we have to then move our machines because of blasting that might be happening in such areas. And also sometimes you'd find that holes are staked in pushback patterns or benches. So in such cases, you'd find that those holes don't last long. So we are not able to track or rather monitor the water changes in them because of them being destroyed. So these are some of the challenges that we faced in the dewatering process. So in order to have the solution or rather the strategic planning in order to combat some of the challenges that we were facing, I've come up with a possible way forward, which includes the baseline assessment. In this stage, it involves understanding of the overall geology, hydrogeology, and structures in a regional and local scale in order to identify the need in terms of the resources of the dewatering requirements, and also integrate other baseline studies that are done in order to understand the overall setup that we're working with, and then go on to do the hydrological characterization. I've realized that so we had a challenge also in terms of identifying the sources of the groundwater that we are working on. So there are possibilities of the stable isotopes that can be used, the tritium and carbon-14 as well, just to understand the sources of this groundwater, which will then help us to manage them properly. And also the need in terms of the hydraulic properties of the ore body, and also the aquifer on its own as well. And also merging and having to merge the drilling programs, which involves the hydrological, geotechnical, and also exploration at large. I think it will then help us to have a better understanding of the aquifers that we're working with, and also having things like pilot drilling for test holes. For an example, if we are targeting a deeper hole, then we can start probably with a shallower holes in order to test if there is any water strikes that we might be encountering, and also using various methods in order to understand the structures in the area, like implementing the geophysics information data as well. And then collating everything into a conceptual model that can then be fed into the systems monitoring system design, which will then have to include meters and also centralized system that has all the information, or the geotech information, the exploration information, the hydrogeology information, centralized to understand how they work. And then at Mokalakwena, we have the piezometers. However, it's a bit of a challenge because they're not in all, in terms of all the pits. So yeah, to develop such things, I think it will assist, and then continue having monitoring holes in order to have tracking of the water levels, and then advise to feed the information into then the geotech as well for slope stabilities and all. So yeah, thank you. Any questions?
Thank you so much. That was so interesting. My first encounter with master drilling was actually in South America, in Peru.
Oh,
So
okay.
yeah, I know they are everywhere.
Yes.
Do we have any questions for Despina or any comments?
I have a question.
Please go ahead.
Hi, Despina. It's so nice to
Hi.
see another geologist going into the hydrogeology sector. I feel like it gives us a good baseline to be able to interpret, like you were saying there, to be able to spot these gaps. So I've worked on projects before where you can incorporate that geotechnical and the core databases. So it's become like a commonplace for me. And it's not something that's often done in the hydrogeological spheres. But it's good that you're looking at that. Definitely use those core data sets from the mines. Take those all your geophysical data sets that they have for the downhole core logs, and try and interpret those structures and stuff. You'll be surprised what you can get from that, just to try and get a baseline assessment of your hydrostratigraphic units. So it's good. It's good that you've done that. And tell me, I see your deeper holes, they went down to 400 meters. Did you guys ever have an experience where, obviously, sometimes when you get big water strikes at depth, you sometimes have where you can't actually even flush that water out of the borehole, and your drilling production rate actually goes down, and you have to, did you guys ever had to add boosters or anything like that to try and compressors to try and get through those zones? Or what did you guys do when you encountered those big water strikes at depth?
Yes, so thank you actually for your comments as well. So yes, we, in terms of the deeper holes, would have booster compressors as well. So would have the booster compressors as well. And yeah, it would be difficult. Sometimes would take about 3 to 4 weeks, and also even sometimes 2 months, including breakdowns in drilling just one hole because of the bit diameter as well. It would go to up to 18 inches as well in terms of the diameter of the bit. So yes, would have those challenges. Yeah. So, but we tried with the booster compressors as well. So it was, and also I would say our machines, they are quite good in terms of, yeah, able to maintain such huge work. But yeah, I think would have breakdowns there and there, but it was like we managed. Yes.
And that sounds perfect. Yeah, we also used to drill deep holes, and it takes a very long time. People they underestimate how long it actually takes to drill a wide diameter borehole down to depth and keep those water strikes open. So yes, no, well done. This is very good.
Oh, thank you.